Multiplying numbers in exponential form. In order to multiply numbers in exponential form, we first need to remember what exponential notation actually stands for. In exponential notation, you have two different numbers. The bigger number is your base, and the number that's more up in the air, this is your exponent. Exponential form is a shorthand version of how to write a larger number. And the thing that you want to remember is that your exponent represents the number of copies that you have of your base. So in this example, the 4 is the number of copies. We're going to have 4 copies of 3 being multiplied by each other. And this representation of 3 times 3 times 3 times 3 is the factored form of 3 to the 4th power. Pause the video here and try this one on your own. When you are finished, unpause and see if you got your answer correct. Now, with 7 to the 5th power, 5 is the number of copies, and 7 is what we're writing 5 times. And again, they're being multiplied by each other. So 7 to the 5th power is the same as 7 times 7 times 7 times 7 times 7. Now that we've reviewed how to rewrite numbers in exponential form in factored form, we can move into how we multiply numbers that are in exponential form. So if we look at the first example, we have 2 copies of 5 being multiplied by each other. And then we have 5 more copies of 5 being multiplied by those first 2 copies of 5. So if you notice, we have the base number 5, and we have written it 1, 2, 3, 4, 5, 6, 7 times. So this is the same as 5 to the 7th power. Take a second and see if you can try the next example on your own. Pause the video and then unpause to see if you got it correct. So with 2 to the 2nd power, that would be 2 copies of 2 being multiplied by each other. And then 2 to the 4th power would be 4 copies of 2 being multiplied by each other, as well as by the first 2 copies of 2. So what number is written over and over again? That would be 2. And we've written it 1, 2, 3, 4, 5, 6 times. So we have 6 copies of that 2 being multiplied by each other. So again, pause the video here and try the next 2 examples. Unpause the video so that you can see if you got them correct. In this third example, we have 3 to the 7th power. So that would be 7 copies of 3 being multiplied by each other. And then we have 2 copies of 3 also being multiplied by it. So, whoops. So you can see that we've written 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 times being multiplied by each other. In the next example, we have a base of x that's first being multiplied 3 copies of itself by each other. Oh, and I'm just going to change it to match the coloring. And then we also have it being multiplied by 5 copies of x. So our base of x is being multiplied by itself 1, 2, 3, 4, 5, 6, 7, 8 times. Sometimes you'll have a little bit more complex expressions to rewrite, but it's the same concept. First, you see 3 copies of x being multiplied by each other, and then those x's are being multiplied by 2 copies of y, and then we're multiplying that by another copy of x. Notice that there's no exponent, and whenever there isn't an exponent, if that's just a 1. So we would just write that x one time. And then we have 2 copies of y. So how do we simplify this? Well, we can go a step further and we can see how many copies of x did we have. 1, 2, 3, 4. So that would be x to the 4th power. And then we have to look at our y's. Well, our y's, we have 1, 2, 3, 4. So that would be times y to the 4th power. Pause the video here and try the next 2 examples on your own. Then unpause and see if you came up with the correct answer. Okay, for the next example, we have 2 copies of 7 being multiplied by each other. And then we have 3 copies of x being multiplied by each other. Another copy of 7, because there's no exponent. And then 2 copies of x being multiplied with that as well. Now, this time I didn't conveniently color code it the way I did the last time, but that's okay. Remember, we have 1, 2, 3 copies of a base of 7, so that's 7 to the 3rd. And then what we have left is 1, 2, 3, 4, 5 copies of x being multiplied by each other as well as by 7 to the 3rd. Notice that it's not necessary to put the multiply sign in between each of your bases. Okay, so for the final problem, we have a 2, and you can notice there's just 1 copy because there's no exponents. We have 2 times, and then we have 4 copies of a base of x, 1, being multiplied by each other. Then we have a base of 3 with no exponent, so that's just 1. We have a base of x that does not have an exponent. Okay, a lot of people get confused here because they want to take that 2 and apply it to the x and the y, but it's only on the y. So then we would have 2 copies of y. So you'll notice that we only have 1 copy of 2, so we would put that first because in standard form we always put our coefficients that are numbers first. Then we have another number, which is just 1 copy of 3. So then we would move on to our x's, and we have 1, 2, 3, 4, 5 copies of x. And then finally we have 2 copies of y, which would make it y squared. Now this answer is fine, but we can simplify it a little bit more. We know what 2 times 3 is, and that's 6, so we can simplify it more by multiplying those 2 coefficients together since they're both numbers. So our final answer would be 6x to the 5th power, y to the 2nd. And that is how you multiply numbers in exponential form. So if we look back at our examples, there is a pattern that makes it a lot easier than having to expand it every time. Notice if you look at the exponents that we started with, and then you look at the exponents in our final column over on the right, what do you notice about this part of our expression and our simplified version? What you should notice is that our bases stay the same throughout. Here we have 5, and in our final answer it's a 5. In the next example, we have 2's being multiplied, and 2 is in our final answer. So notice that in each of these, our bases is staying the same. So as long as we have the same bases, you should notice that something's happening within our exponents. And Notice our final exponent on this first one is 7. Well, 2 and 5 make 7. In the next one, the final exponent is 6, and 2 and 4 make 6. Go ahead and check and see if it works for the last two problems as well. And you should have seen that, yes, it does work for the last two as well. Well, what about with more complex problems? Well, notice as long as the base is the same, we have this 3 and this 1, you can see that that's what we drew, 3 x's and 1 extra. And if we add those, we get our exponent of 4. And then the same is true with the y's. Here we have 2 y's and 2 more y's to give us y to the 4th. So, in conclusion, what we can say is that if we have exponential numbers that have the same base, we can add the exponents to simplify our expression. And then, of course, just remember that the base stays the same. So if we have 3 to the 5th power times 3 to the 4th power, you can see that our bases are both 3. So we can just add our exponents and get 3 to the 9th as our final answer. And that is how you multiply exponential numbers with the same base.